Hey everyone, thanks for joining us again today. This time I'm going to ask Sean a logic question. So, um, this won't require much coding, but I do want Sean to walk us through his thinking and
Yep.
to practice thinking out loud. So,
Wait, are you streaming?
yeah,
Okay, gotcha. All right.
okay. So, Sean, this time the question is so you have two jugs. Um, you have a 5 quart jug,
Mm-hmm.
and you have a 3 quart jug,
Mm-hmm.
and you have an unlimited supply of water. So, how can you measure 4 quarts using the two jugs, or yeah?
Okay.
And one thing to keep in mind is that these jugs are irregularly shaped, so you can't just say, okay, I'll measure half of it.
Yeah. Okay. Um, so I've done this problem
Mm-hmm.
before, but I'll try to go through my thinking process.
Okay.
Yeah. So let's see. You have 5 quarts. You have a 3 quart. By taking the difference, you are able to. So let's see. Okay. Um, so one thing you can do is kind of use the difference between the cores
Mm-hmm.
to get additional measurements.
Mm-hmm.
So, for example, you can fill, you can put 3 quarts
Mm-hmm.
of water
Mm-hmm.
in the 3 quart jug,
Mm-hmm.
fill it in the 5 quart, fill another 3 quart, and then you can fill up two from the 5 quart using the water present at the 3 quart to get 1 quart of water left in the 3 quart jug.
Wait, so how would this how does this work? Can you okay, so you start with
So you can say first you get 3 quart
uh-huh.
water in 3 quart
Okay.
jug,
Yep.
right?
Mm-hmm.
Let's so I'm gonna just take out the quart so I don't have to type it. So when
Sure.
we say a number, just assume
Mm-hmm.
if it's 3 water, that means the volume,
Yep.
and then inside the
Mm-hmm.
jug, which is
Okay.
the size
Yep.
of 3 jug. What we do with the three is you pour all the 3 quarts of the water into the 5 quart.
Mm-hmm.
Or 5 jug, which is
Mm-hmm.
empty. So what's left is uh, 0 in the 3 quart and 3 in the 5
Okay.
jug.
Yep.
Then we can say if we.
Actually, sorry, do you mind if I interrupt? So
Oh,
maybe
sure.
to make this easier, we can use I think for this case, we can use just a table. So we have,
Okay.
uh, so this would be maybe how much is in the 3 quart jug, and this would be how much is in the 5 quart jug, and this is what action we take.
Oh,
Would that
sure.
would that be easier? So
I see. I see.
yeah,
Okay, so we
and then
can
if you want to
do.
add a new row, you just need to press tab, and then like when you're tabbing here at the end,
Okay,
it'll add a new
all
row.
right.
Yeah.
So first we fill the 3,
Mm-hmm.
and then this will have 0.
Yep.
Then you transfer the 3 into the 5. So transfer to 5 jug.
Mm-hmm.
So now you fill the 3 again here. So this will be fill 3 jug. So we know that 2, in order for 5 jug to be full, it only requires 2 quarts. So you fill it with that, with the 3 jug. So this will be 5. So fill 5 until full 3 jug. So now we have a way to measure 1 quart.
Okay.
So since you want 4 quarts, we can pour out all the. So we use this 1 quart, and then we use the 3 to fill it again. So dump. Let's see. The 5 jug. Pour the 1 quart into the 5.
Okay.
Then you fill the 1 jug again. Or the 3
Okay.
jug again. Then transfer everything into the 5 quarts. So in the 5 quart jug, you have 4 quarts.
Cool. So is there a way you can generalize this, or let's see, I guess
generalize,
or given you know two jugs of different sizes, can you what amounts can you figure out using this? Say like a jug of size X and size Y.
Okay. Given jugs X, Y, what sizes? Oh, so sizes. We know already we can do X and we can do Y. Let's see. Here we've gotten 1. So when the 3 transferred to the 5, what you did was, okay, so the 5, we got X, so assume X is smaller in this case. Smaller size. What we did here was we used the difference between 3 and 5, subtracted from the 3. So I guess we can also just do Y minus X, that is a legit size.
Yep.
Compute. We can also compute, so in this step here, we've computed X minus Y minus X. X minus Y minus, so what is that, 2X minus Y? Okay. Yeah, okay. So let me check that. So 2x is 6 minus 5 is 1. Okay, that seems to work. We've also figured out 4 in this case. tricky. So we know 1 is there.
Mm-hmm.
So probably x. What is it? 3x minus y
Mm-hmm.
in this case. What's just can you figure out? Is this what you're looking for?
Sorry. Yeah. So actually, I realized that for this so for this question so I think to actually generalize it would be too
Yeah, I
much for
guess
just
y can
one
be
session.
really big and this will
Yeah.
all be negative. So
But
that depends on the size.
yeah, but so this I don't think you would have been able to just figure out. But yeah, I think I'm gonna stop you here and we can move on to the next one. So but the thing is, if the two jug sizes are relatively prime.
A relatively prime?
Yeah, relatively prime. So like if
okay.
yeah, they have no common. So
Oh, I see.
yeah,
Okay.
so you can actually measure any value between 1 and the sum of the jug sizes.
Okay. Interesting. Relatively prime meaning that they are consecutive primes of each other?
So here 3 and 5 are relatively prime because so they can't. Okay, let me just look up the definition real quick. Relatively. Okay, so they don't have any common factors. So like, say 6 and 9 are not relatively prime.
Oh, I see.
So, but then 3 and 5 are because the only positive integer that divides them both is 1.
Yeah. So 2 and 5 are relatively prime as well. In that case. Okay. Alright.
And then 8 and 9, even though neither of them are prime numbers, they're relatively prime as well.
Yeah.
Okay. Cool. Let me stop streaming first, and then we can move on to the next one.
Did you have another question?
I did, yeah, I did.